Solution 3. In the former class, I have discussed solution 1, solution 2. That is, I have discussed about the vapor pressure of a pure solvent and that of the solution, and I have discussed also the colligative property, especially the relative lowering of vapor pressure. Today, I want to discuss ideal and non-ideal solution. Ideal solution. The solution which obeys Raoult's law is known as the ideal solution, and the solution which does not obey Raoult's law is called non-ideal solution. If A and B are the two components, that is solvent and solute are two components, they mixed to form AB is the solution. For ideal solution, the intermolecular force of attraction between A and B similar to those of their pure components. The attractive force between A and B molecules, that is solute and solvent molecules, are not similar to those of their pure component, that is AA and BB. This is not ideal solution. For ideal solution, there is no heat evolved or absorbed. The change of enthalpy is equal to 0. Delta H of mixing is equal to 0. That is, there is no change of enthalpy. But for non-ideal solution, delta H of mixing is not equal to 0. That is, if the solid particles are dissolved in a solvent, then there is a significant change of heat. That is, there is change of enthalpy. Delta H of mixing is not equal to 0. 3. For the ideal solution, when the solid particles are dissolved in a solvent, then the volume change is 0. That is, delta V of mixing is equal to 0. And for non-ideal solution, delta V of mixing is not equal to 0. If we add 100 milliliter of solvent with the 10 milliliter of solute, the total volume is 110 milliliter and the volume remains same. It does not change, and there is no change of volume. But for the non-ideal solution, the change of volume occurs, that is, delta V of mixing not equal to 0. It may be positive or may be negative. That is, the total volume, that is 110, it is greater than 110 or less than 110. 4. For the ideal solution, the vapor pressure of their components is equal to their partial pressure. That is, P1 is equal to P01x1 and P2 is equal to P02x2. That is, ideal solution obey Raoult's law. But for the non-ideal solution, P1 is not equal to P01x1 and P2 is not equal to P02x2. It does not obey Raoult's law. These are the differences between ideal and non-ideal solution. That is, ideal solution mainly obeys Raoult's law and non-ideal solution does not obey Raoult's law. These are the main differences between ideal and non-ideal solution. Now we have to discuss about the non-ideal solution only. For the non-ideal solution, there is positive and negative deviations. And the positive deviation occurs when the intermolecular force of attraction between solvent and solid molecules is low. And the negative deviation occurs when the intermolecular force of attraction between A and B is high. Now let us look. Now we want to discuss about the positive and negative deviation of non-ideal solution. positive deviation, negative deviation from the ideal behavior. 1. E of AB is less than E of AA or E of BB. Here is E of AB is greater than E of AA or E of BB. The intermolecular force of attraction between A and B, that is solvent and solid particles, is less than E of AA or E of BB for the positive deviation. And if the intermolecular force of attraction between A and B, that is solute and solvent particles, then a significant expansion of the volume occurs. That is, delta V of mixing is equal to positive. If the attraction is low, then the expansion occurs, that is volume expands. So the delta V of mixing is positive. For this case, intermolecular force of attraction is higher. If the intermolecular force of attraction is high, then a significant contraction occurs. That is, volume is lowered to some extent, and there is negative change of volume. That is, delta V of mixing is equal to negative. As the intermolecular force of attraction between A and B is low, then there is change of enthalpy. That is, the enthalpy change must be positive. That is, delta H of mixing is equal to positive. That is, endothermic reaction occurs. Endothermic reaction occurs. Actually, for the total system, energy is absorbed. That is, delta H of mixing equal to positive. For this case, delta H of mixing is equal to negative. That is, exothermic reaction occurs. Exothermic change. Exothermic change occurs. Here, endothermic change occurs. The energy required to break this bond is higher, or energy required to form this bond, to break this bond, is higher than this, and delta H of mixing is negative. And here, for positive deviation, P1 is greater than P01 x1 and P2 is greater than P02 x2. That is, the attractive force between A and B is less. Acceleration is high, then the vapor pressure is high. That is, P1 is greater than P01 x1 and P2 is greater than P02 x2. But for negative deviation, the attractive force between A and B is higher than that of AA and BB. So there is less escaping tendency of the components, and the vapor pressure is low. That is, P1 is less than P01 x1 and P2 is less than P02 x2. This is the negative deviation. Or these are the positive and negative deviation. These are the differences between the positive and negative deviation, which can be explained from the intermolecular force of attraction between AB, AA or BB.